Part of the reason we learn quadratics is because we can actually use them. They really use quadratics in real life. Today, what we're going to do is we're going to drop people from a height. And I think we should drop Mikey. Okay? So we're going to drop Mikey today. Well, okay, so there's two kinds of problem. There's a dropped and a launched. So the dropped, I can just be mad and push him off the top of a building and he's going to fall, right? I can push you because I'm stronger than you, Mikey. All right, but the launched, I would have to pick him up and throw him. And probably, that's probably not going to happen. It might, depending on how mad I was at you. But for today, I'll just be pushing him off the top of the school building, and we'll just see how long it takes for him to go kersplat at the bottom, okay? So first of all, right here is the formula we're going to use. And the H0, that's my initial height. So that's how high we start pushing Mikey off the top of the building. So this is initial. I'm not spelling right. Initial height. That's all spelled wrong. Lord. Jack, do you want to get pushed today? No, you're not pushing me back. That would be mean. Well, you deserve it. Okay. So we're going to push Mikey off the top of the building. So let's look at the first problem. We pushed Alan last period. Okay. So this is Mikey. And he's going to drop, it says he dropped something, but we're dropping him. Okay? So I want to know how long it will take him to hit the ground. So first of all, my x value is always time, and my y value is height. The x value is time, and the y value is height. This is why you're getting pushed. You're going to hurt me. Don't hurt me. That was not kind. You should let me push you, but not push back. That's the kind thing to do. Okay, you could have hurt my back or something.
We trying to say I'm fat?
Oh my gosh, I think I could get workman's comp. Come in. Hey. Okay. Sit down. Okay, so the x is the time and the y is the height. So this is asking for time. It's asking for time. So it wants to know how long it's going to take Mikey to fall from this 144-foot building. So this is 144. Here's Mikey. And he's going to fall. And he's going to go kersplat. And I want to know how long. How long? So the first thing I'm going to do is I'm going to enter this. I'm going to follow the formula that's given at the top. I'm following that formula. So that's minus 16t squared. And then the initial height that we're pushing him from is 144. So turn on your handy-dandy calculators and go to y equals and typing in the first line, we're going to type that in. This is the equation that we're going to start with. And what height do I want to know for him to be at? If he's going to hit the ground, what's the height? 0. So in my y2, I'm going to put a 0. So in my y2, I'm putting a 0. Now, let me just ask you a question. Just by looking at this, first of all, the negative means which way is the parabola going, up or down? It's down, right? Which makes sense because he's falling, so it's down. Also, the plus 144, that's a shift which way? Is that in the parentheses? Because in the parentheses would be x. So this is an up, right? So I take this and I'm shifting it up, which also makes sense because it's going to be at the top, correct? The vertex is at the top. So if this is plus 144, how tall does my window have to be so I can see this? Am I going to be able to see it if the top of the window is set at 10? Why? Because it's at least 144, right? At the very minimum, it's 144. So push your window and look at your Y max. What is your Y max set at? So if we change that to 150, let's graph and see if we can see the top of the parabola now. Can we? We can see the top of the parabola. Can I see where it's hitting the ground? Does that show? Right here? Yours doesn't show? Okay. So as long as you can see both, because if you can't see both, you're not going to get an answer. It's going to tell you sign change something, or I don't know, it's going to give you an error. You got to be able to see both. And if you get a sign change error, you have to change your window. So what I want to know is, I want to know this spot right here. This is where he goes kersplat. So I'm going to push second, trace, and I want to go to intersect. And push enter. So I want the answer. Do I care about the first curve? I don't. Push enter again. Do I care about the second curve? I don't. Push enter again. Do I ever let you guess in here? Never. Push enter again. And look, Mikey, it only takes you 3 seconds to fall off the top of the building. That's it. The next question says, at what time will Mikey be 6 feet above the street? Yes. Yes. We'll use Jack next time. But this time you're 6 feet, okay? So what's going to change? What's going to change when I do this? Does the initial height change? What changed? The y2 changes from 0 to 6. So I'm going to change my y2 to 6. Graph it. And we're going to find the intersection again. Second, trace. Not the first curve or the second curve or the guess. So my intersection, this time, Mikey, you're only taking 2.9. Okay, so for the next one, Jack. Jack is on a cliff. Oh, let's make this pretty. Look, make the little cliff, and it's 16 feet. Let's add some water down below. Yeah, he got water. He's diving into the water. So here's Jack. And Jack is diving into the water. So Jack only starts at 16 feet. It asks what time will Jack be halfway to the water's surface. So if he starts at 16, what's halfway? So where does that 8 go? 8 goes in Y2, and where does the 16 go? Come in. Graph it. Okay, so first of all, why is my parabola so small? It's still on 150, so what's probably a better choice for my y max right now? So if it's 16, right, let's go with 20. So right here is what I'm looking for. I'm looking for the time right here, and the time is my x value, so I'm going to push second, trace, intersect. Jack, you're trucking. It's 0.707. Okay, any questions?